Exercise 10, that was our first homework question. So let's take a look at what you have. Okay, so this is the presentation that I'm expecting here. So y is directly proportional to x squared. Straight away you can write down y equals to k of x squared. This is now our formula. We will be substituting things inside. We can substitute, for example, if they tell us y equals to 50 when x equals to 5, for example, we will substitute those numbers in. Instead, most of the time, they'll tell you that when y is a certain value, x is a certain value. So we use yo and xo to represent it. Okay? They may tell you that, oh, y is equal to 35 when xo is a certain value. Then they don't tell you the value, so you use xo as a substitution for the value x. Okay, so let's continue. X is increased by 50%. So over here, this tells us that there is an original value of x, which I call xo, became, okay, it increased by 50%. When something increases by 50%, the final value is now 150%. Okay, so the final one will be x new, which is equal to 150% of xo. Now, all these parts are a lot to write. You don't have to do that. Straight away in your mind, you should have the ability to say that xn is just 1.5 xo already. Okay, when they tell you that it is increased by 50%, straight away you should be able to write xn from here, x new equals to 1.5 xo. Okay, that is what you should be able to write. So now, then after that, then you find the percentage increase in y. So how does the y new compare to the yo? Now we substitute in the original values first. So yo equals to kxo squared. This is the original, what happened initially. Then we have a new value of y that we are trying to find out how it changed. So we substitute yn into the original formula. It is equal to k times of xn squared. Okay, watch. It is just the corresponding x and a y. But I know xn is related to xo by this relationship. So instead of having so many different variables, I'm going to replace my xn with the entire 1.5 xo, close bracket. And you notice that the square belongs to the entire 1.5 xo. Now, because this was your homework, I just want to check. I want you to check. Did you write instead yn equals to k 1.5 xo squared? Did you write something like this? Because this is the common mistake that students always make. They think that y is directly proportional to x squared, then x is increased by 50%. Yeah, so they say, oh yeah, so this is my increase by 50%, I get 1.5. Then we have an xo squared. And then this will be wrong already. Because in red, this gives us 1.5k xo squared in red. Whereas, and this is wrong, whereas this over here gives me 1.5, which is 3 over 2, 9 over 4. 9 over 4 kxo squared. See, 9 over 4 and 1.5, they are different. You see that? So from here, we recognize that, hey, kxo squared has already appeared before. This is like your equation number 1 and this is your equation number 2. They are separate. But they all came from that same formula. So you compare to equation number 1, kxo squared is the same as yo, the original y. So what this tells us that, hey, your new y is equals to 9 over 4 of the old y. Not the original y. Now we have a relationship. When my x was increased by 50%, my new y actually increased by this amount, which is not 50%. Therefore, percentage increase. You can write down already. Percentage increase will be the final 9/4 YO minus the original YO divided by the original times 100%. So 9/4 YO minus one of them, you get 5/4. So 5/4 YO in the numerator divided by YO, you get 5/4. So 5/4 times 100%, 25 times 5, you get 125%. Is this correct? I didn't bring my calculator. Is this correct? Somebody with a calculator, can you check? 9/4, so 5/4 times 100. 5/4 times 100, 25, 125, okay, correct. So this is the percentage increase. When one increased by 50%, the other didn't increase by 50%, it increased by 125%. So much. Okay, then we move on to the next one. Now exercise 12, y is proportional to x cubed. Y equals to k of x cubed. This is our formula. We will be substituting things inside. Let's see what we can substitute inside. Oh, it is known that y equals to 24. 24 equals to k, a particular value of x. Now, a particular value of x, what would you write? XO lah. Okay, a particular value. I don't want to just leave it as x, because x is a variable. But when they say a particular value of x, they are telling us that it is one value of x. That one value of x, it may be a 3, it may be a 5, we don't know what that is. That's why we call it XO, to indicate that there is a value over here. It is not just a random x, it is not a variable anymore. So find the value of y when this value of x is halved. When this value of x is now halved. Okay, so back to our equation, back to our formula. We want to find the new y when we have a new x, correct? We are substituting into the original formula. I want to find a new y when I have a new x. Then now I need to think about what is the relationship between the new x and the old x. Relationship between the new x and the old x. So information was provided over here. This value of x is halved. This value referring to XO. And they're going to halve this value. In other words, this statement tells us that x new equals to half of XO. And now I can substitute that inside here, giving me k times of XO over 2 power 3. Or you can write it as half XO, scan, half XO power 3. And then you should realize that we have to expand k times of 1 over 8, because half to the power 3 is half times half times half, which gives us 1 over 8. Then we have XO power 3. You notice it's the same few steps all over again. Number, put it in front. So 1 over 8 times of k XO power 3. And you notice that it's the same kxo power 3. It is always done this way. It will appear again. Right? And what is this highlighted value? So I brought earlier on, I brought in the idea of what we did similar to our simultaneous equation. These are two separate equations. Two separate equations. And we're going to substitute this value, 24, inside here. So our new y turns out it is going to be equal to 1 over 8 times of 24, which is 3. Over here, 3. Okay, it is not as simple as, original y is 24, then when my x is half, then my y also half lah. Then 24 became 12. No, it doesn't work that way. But I still expect to see that during your test lah, if you don't understand what's happening. but I hope not. Any questions? Okay, this is also your homework. So now y is proportional to x squared. Oops, kx squared. Kx squared. That is for our first line, and that is our formula. It is known that y is equal to 3. Okay, 3 equals to k for a particular value of x. Again, a particular value of x, we're going to call it xo, the original. So xo power 2. Find the value of y when this value, they are talking about our xo, is now doubled. In other words, they are telling us that x new equals to 2xo. Okay, so this is our kind of like our first equation. Now my second equation is my y new k times of x new squared. This is my second equation. But my x new is 2 times of xo. So we can remove that. 2 times of xo, close bracket. The square belongs to the entire 2xo. Then we get, I'm going to skip one step. I'm going to put a number in front already, 4kxo squared. Okay? Then you see the same thing again, kxo squared, kxo squared. What does that equal to? It was equal to 3. So replace it, 4 times of 3, and you get 12. And now, who got these two, the last two questions correct? The last two questions that I just went through. Who got it correct? Raise your hand. Just let me see who got it correct by yourself as homework. Only 2 people. Sean, did you get it correct? You got one of them correct. Okay, who got both wrong? Both wrong? Raise your hand. Both wrong? Don't be shy. We are learning, okay? Who got one correct? One wrong. Okay, okay, good. We'll practice, Make sure every single example, you are learning something. Every time you get it wrong, you find out where you went wrong, and you don't make the same mistake again. So now I will pause over here. Next one, question 14. Y is proportional to the cube root of x. So let's form the equation. Y is equal to k times of the cube root of x. Oops. Now they tell you that it is known for y equals to 10. So this is our yo. Okay, it has a value of 10. For a particular value of x, this is our xo. In the past two examples, I think I just wrote 10 equals to k cube root of xo. I would have written something like that. Then I realized that some of you are wondering where's the yo. Yeah, okay, this is our yo. This 10 is our yo value. Okay? This is effectively our first equation. This is the first time we are substituting things inside our formula. Then they tell us, find the value of y. That means they want us to find the new n. Find yn. When this value of x is half. This value of x. They are talking about xo. Xo is now going to be halved. So the new x is just half of the old x. So just put it down over here. The new x is just half of the old x. Now we're going to form our second equation, where we have y new. I don't know what that is, but it is going to be k times of the cube root of the new x. See, I'm just substituting new x, new y into the original equation. But at this time, I remember, I have a relationship between the new x and the old x. So instead of having another unknown over here, we should replace it with something that we have an expression for. So this is our half xo. Now I'm writing my new y in terms of the old x. Objective is to change our expression on the right to extract out the old y. And we can do that because this is simply k times of cube root of half times the cube root of xo. This was our second equation already lah. Okay, we are substituting something else inside already. So what I did over here was to separate the power 1/3. Okay, now cube root of half is just a number. Just like any other number. We put it in front. You can use your calculator to work out what that value is. K cube root XO, and we see again that K cube root of XO, K cube root of XO has already appeared. It has the value of 10. So this is cube root of half times 10. And that is our new Y value. So use your calculator to find out the value. Then round it off to 3SF. Which you can do by yourself. Okay, next one, exercise 15. Okay, this one is the O-level question. Let's see what an O-level question looks like. A group of solid cylinders, they have equal heights. Okay, a group of solid cylinders, they have equal heights. They didn't say anything about the radius so far, so just have different radiuses first. The mass for each cylinder is directly proportional to the square of its radius, or cm. Does that make sense? Since they all have equal height, they are now telling us that the mass is directly proportional to the square of the radius. Mass directly proportional to the square of its area. M equals to K times of R squared. They are telling us that this is the formula that you should be using. You can actually use your Sec 1 work to determine whether this is true. Because you know how to find the volume of a cylinder. And then for a cylinder of the same density, the mass would then be directly proportional to the volume, which is in turn proportional to the square of the radius. You can go and figure out why that is so by looking at the formula for the calculation for volume of a cylinder. Okay, now they tell us that the cylinder with radius of 4 cm has a mass of 720 grams. Then find M in terms of R. Okay, so based on our fundamental skills, we know that in A part 1, we can write down M equals to K R square already. Standard, right? Mass directly proportional to the square of the radius. Then we're going to put in this piece of information. This is the old radius, RO, and this is the old mass. We are going to put this information inside, and we see that 720 is equal to K times of 4 square. And then you can find the value of K. So therefore, K will be 720 over 16, resulting in, I don't know, version what is it? 45, 45. So now I have a value of K. Then find a formula for M in terms of R. Remember, I always start off saying that this is our formula. And this is the formula, but you must write down the value of K. We found the value of K. You substitute it back in. So M equals to 45 R squared. This is the answer for part A, part 1. Okay, you cannot just expect to write M equals to KR squared. Yeah, you get your 1-2 marks. Not as simple as that. You need to tell me the value of K, which can be found by substituting the value of RO and MO. Then in part 2, find the mass of a cylinder with a radius of 6 cm. This is now our updated formula. Which we are going to be using. So find the mass. Mass equals to 45, the radius 6, and you square it. I'm just going to copy down the answer, 1620 grams. Okay, this 1620 grams refers to a particular mass. So strictly speaking, we should be calling this M something. We shouldn't be leaving it as just M. But generally, we are okay with this. We are okay with you just writing M equals to whatever in this particular case. But if you really want to be very clear about your work, you should give it a name. M something. So instead of M old, M new, which probably is going to be used in the next part, I don't know, you can give it some other name, M something. I suggest you can call it M6. 6 for 6 cm. That's my suggestion to you. Okay? Next time we have M radius 2. Hey, M2 lah. M whatever the radius is. It's just a notation to help you identify quickly this mass corresponds to which radius. Otherwise, like I said, it is fine to leave it out in this particular case. Next one, part B. One of the cylinders A has a radius 50% greater than the radius of the cylinder B. Wow, now we have two different radius, and we don't know both of their radius, right? Are you going to call it R1, R2 or RO, R new? Or do you have a better way of calling them? Yeah, RA, RB lah. Okay, so radius for A will be RA. The radius for B will be RB. However, we know there's a relationship between RA and RB. RA is 50% greater than RB. So you can either write one A in terms of B or B in terms of A. Based on the sentence, it is actually a bit easier to just say RA equals to 1.5 RA is actually 1.5 times of RB, correct? 50% greater than the radius of B. So every time you're going to be using radius A, how about this? We just use 1.5 radius B. So that effectively removes one unknown already. Instead of RA and RB, we actually have only RB and 1.5 RB. Only one unknown. Less confusing, less work to do. Okay, let me write the 5 properly. Okay, this is from the first sentence in part B. Then now they tell us, write down the ratio of the mass of cylinder A to the mass of cylinder B. Mass of A to mass of B. Instead of writing a ratio, I hope you remember your set 1 word, we want to write a fraction. If they want ratio of mass A to mass B, MA over MB. We rather use fraction. Later on, once we obtain the fraction already, then we convert to ratio. So MA over MB. Back to our updated formula. MA will be 45 times of RA squared over 45 times of RB squared. Then you're stuck. Oh. Okay, not exactly stuck. 45 can cancel. RA squared over RB squared. I don't even know what's RA squared and RB squared. How to do? Then don't panic. Remember what we just talked about. The relationship between RA and RB. And every time you see the RA, you change it to 1.5 RB. So RA, 1.5 RB, and you square the entire numerator. Divided by RB squared. Then you end up with 9 over 4 RB squared over RB squared, which is 9 over 4. With this, MA to MB is 9 to 4.